Hello, my name is Alexa Gordon. I'm a second-year PhD student at Northwestern University, working with Dr. Wenfei Fong. Today I'll be discussing how we can understand FRB progenitors from their host galaxies. The main goal of my work is to use spectral energy distribution modeling to study FRB host galaxies, specifically focusing on the ages of the hosts. As FRBs have only been detected in the radio so far, we don't have much to go on with studying them. However, we can study FRBs indirectly through their host galaxies. We can use the age of the host as a proxy for the age of the progenitor, and then use that progenitor age to constrain the delay time distribution. This is the time between when the progenitor was born and when the FRB event occurred. However, it's difficult to measure ages. You need very high-quality data, and ages tend to be dependent on your model priors and star formation history. To combat this, you can use a non-parametric star formation history, which is something I'll be exploring soon. To get ages and other parameters of interest for the hosts, I use a code called Prospector to do joint photometry and spectroscopy SED modeling. The advantage of this joint fitting is that you're able to constrain age, metallicity, and star formation rate better than photometry-only fits. Currently, I've been working on fitting the 13 localized host galaxies in Heinz et al. 2020 and have some preliminary results to show. This figure shows the cumulative distribution function in comparison of ages for 6 of the fitted hosts to the values reported in Heinz et al. 2020. Overall, the PHOT plus spec fits show systematically larger ages than the PHOT-only models. This is a Prospector SED output for FRB 181112, and an image of the host galaxy from Bhandari et al. 2020. What you see in the top panel is the observed photometry in spectrum in purple, and the model photometry in spectrum in green. The bottom panel shows the respective transmission curves. You may wonder why I chose a burst with such a noisy observed spectrum, which is the purple line. I did so to highlight that Prospector is able to see through the noise and pick out and model the important emission and absorption lines. Here you can see H-alpha, H-beta, and the oxygen-3 doublet clearly resolved in the green model spectrum. This shows that Prospector is a powerful tool for modeling spectral information, even when the observed data aren't perfect. So far, we've seen that Prospector PHOT plus spec fits tend to produce larger host ages than PHOT-only fits. What this means yet, I'm not entirely sure, but it's something I'll be exploring in the coming months. The next steps are to finish the 13 localized hosts, analyze their properties, and see what we can conclude about the FRB progenitor. I will also explore a non-parametric star formation history. For any questions, please send me an email. Thank you for your time.